number 10. When brakes are applied to a bus, the retardation produces 25 centimeter per second square. So A is equal to negative 25 centimeter per second square. So 0.25 meter per second square, I'm saying. Okay, and the bus take 20 seconds to stop. So T is equal to 20 seconds. And since it is stopping, I'll take V as 0. So to find the initial velocity, so V is equal to U plus AT. V is 0, U we don't know. A is minus 0.25 and T is 20. So this will be minus 5, and therefore you get U as 5 meter per second. So this is the first answer. Okay, the second thing that they have asked is the distance. So I can use S is equal to UT plus half AT squared. So that means U is 5, T is 20, half into 0.25, and T is 20 into 20. Okay, so how much will this be? This is 100, and I will write this as minus. Okay, 0.25 means 4, and you have 20 into 20. So this will give me 10, and this will give me 5. So 100 minus 50 will be 50 meters. Okay, so these are the two required answers. Okay, so we go ahead. The next question. So here we have a car traveling with a uniform velocity of 25 meter per second. So I will write this as U as 25 meter per second, and the time taken is 5 seconds. Okay, so if you read the sentence properly, it says that it travels 25 meter per second for 5 seconds. Okay, so the distance covered by the car, S is equal to UT plus half AT square, is 25 into 5 plus half into 0. Okay, because it was not accelerating. So that is 125 meters. So that's part 1. Okay. Now if you consider the second part, now second part is this. The brakes are then applied. So for that part, if you rewrite, U is 25 meter per second, and it says that it comes to rest. So that means V is equal to 0 in 10 seconds. So T is equal to 10 seconds. Okay. So in that case, what is the distance covered? So first of all, let's find acceleration. V minus U over T. So that is 0 minus 25 upon 10, and that will be negative 2.5. And they are asking for the retardation. So let us write down retardation will be 2.5 meter per second square. Okay, let's find out the distance. UT plus half AT squared. U is 25 and time is 10 plus half into negative 2.5, and T squared is 10 into 10. So this will be 250 minus, now over here, this will be 250 over 2. So 250 minus 125, and this becomes 125 meters. Okay, so the question is the distance traveled by the car after applying the brake. So this is our third answer. Okay, this was our second answer. And this was the first answer. Okay. A spacecraft flying in a straight course with a velocity of 75 kilometers per second. So over here, I take u as 75 kilometers per second. Now, since it is a spacecraft, these are imaginable speed. Every second it is traveling 75 kilometers. On Earth, it is not possible for a car or some vehicle to travel as fast. Okay, now it fires the rocket motor for 6 seconds. So time is equal to 6 seconds. At the end of its time, the speed is 120. So because of the motor, the rocket is now moving faster. That is 120 kilometers per second. Okay, the spacecraft average acceleration. So acceleration is v minus u over t. That is 120 minus 75 upon 6. So that will be 45 over 6. 6 sevens are 42 and 3. So that will be 5 kilometer per second square. Okay. The second part that they want to know is the distance traveled by the spacecraft in the first 10 seconds. Okay, so this is, we need to understand that the rocket is, the motor is only on for 6 seconds. That means the spaceship is accelerating only for 6 seconds. So that 10 seconds have to be broken up into 6 seconds and 4 seconds. So S is equal to ut plus half at squared. So this is 75 into 6 plus half into A is 7.5 into 6 into 6. Okay, so this is 450. And now after 6 seconds, when the spacecraft has attained a speed of 120, the distance covered will be u into t. That is 120 into 4, because this plus half at squared will be 0 because acceleration is 0, and this will be 480. I took it as 21, it should be 18, so this will be 135, and so this will be 585. So 585 will give us 1065 kilometers. Is a pretty long one. So what I'm going to do is I'm going to divide it into parts. So we are going to just read the first part. A train starts from rest. Okay, so this is part 1. U is equal to 0 and accelerates at the rate of 2 meter per second square for 10 seconds. Okay, so let's do only this much. So what are we going to do is we are going to find the final velocity, that is u plus at, that is 0 plus 2 into 10, that is 20 meter per second. Okay, so this is the final velocity. Let's find the distance also. Ut plus half at square, that is 0 into 10, half into 2 into 10 into 10, and that will be 100 meters. Okay, let me call it as some S1. So this is my first part. Okay, so let me use another color now for the second part. The second part is that, okay, this is very light. I'll use green color. Okay, now it maintains a constant speed for 200 seconds. So that means your U is 20 meter per second. time is 200 seconds, acceleration is 0. So S is ut plus half at square is 20 and 200 plus 0, and that will be 4000 meters, and that will be S2. Okay, so this is the second part. That means the train moved ahead without acceleration for 200 seconds. Okay, the next that we are going to see is the third part, and the third part says that brakes are then applied on the train and it uniformly retard and come to rest in 50 seconds. So the train which was moving with 20 meter per second comes to rest, and the time taken is 50 seconds. So again, since there is a change in velocity, we call for acceleration also. So that is v minus u over t, that is 0 minus 20 over 50. Okay, so that will be minus 20 over 50 and negative 0.4 meter per second square. Fine. And let's calculate the distance as well. S is equal to ut plus half at square. So 20 into 50 plus half into negative zero point 0.4 into 50 into 50. Okay, so I will calculate it over here. So this I call it as S3. Okay, so that will be 1000, and this will come out to be zero point 0.4. So that will be 0.4 multiplied by 2500 and into half. So that will be 500. So this is 500 meters. Okay, now let's see what they have asked. So the first question is the maximum velocity reached. So that is this. So this is answer number 1. Okay, the second is the retardation in the last 50 seconds. So this is answer number 2, but that is retardation. So what we can say is retardation is 0.4 meter per second square. Okay, so this is second number answer. The third one, the total distance traveled. Okay, so it will be S1 plus S2 plus S3, and that is 100 plus 4000 plus this is 500, and therefore it is 4600 meters. This is answer number 3. And then the average speed. Okay, so velocity average is equal to total displacement upon total time. Okay, so how much is that? 4600. And the time taken over here, since earlier it was 10 seconds, then it was 200 seconds, and then it was 50 seconds. So this will be 4600 divided by 260. And that answer is 17.69 meter per second. Okay, pretty long question, but you know, you have to take one part at a time and solve it.